Hello, sixth grade, and welcome to your first review for math. So the front page was some definition of terms. I already wrote those down. I'll go over them. As I was going through it, I realized we did not cover percent, so don't worry about percent. It also is not on your test. But the rest of the definitions you do need to know for your test. So the first one is equivalent ratios, ratios that can be simplified or reduced to the same value. So I have an example here of 4 to 6, 6 to 9, and 8 to 12. Those can all be reduced to a factor of 2 to 3. So those are equivalent ratios. Percent, I did put that in there in case you want to just make sure that you have everything filled in and everything's perfect. They are rates out of 100, so an example of 1% is 1 out of 100. Rate then is a quantity that describes a ratio relationship between two quantities. Example in this case would be 15 miles per hour. And then I have the page numbers that you can reference those as well. Ratio then is an ordered pair of numbers which are both non-zero. So we have examples here of A to B with the colons, the A to B with the word, and then A over B. It's actually typically like this. So those are the three ways that ratios can be written. And then last we have unit rate. It's a rate for one of something. So miles per gallon. So we only have 1 gallon. Feet per second. So you're talking about 1 second. Price per pound. You're only talking about 1 pound. So please feel free to fill those in. You can also Google them or find them in the book, the definitions. All right, let's move on to the back then. So question number 2. Brian's mom spent $46.20 filling up her gas tank. If her gas tank can hold 12 gallons of gas, how much did each gallon cost? So we're trying to figure out how much we're paying per gallon of gas. So when you're driving around and you're seeing, oh, hey, gas is $2.94 or $2.99 or whatever it is around here, that's what we're trying to figure out. This is the total price that she paid to fill her gas from empty to 12 gallons. So one way to do this is to set up a ratio. So when we're doing this, we have our gallons or our price to our total. We want to figure out how much it costs per one. So here, to get from 12 to 1, I need to divide by 12 to figure out this space right here. I also need to divide this by 12. So I'm going to grab my calculator here. So I'm going to do 46.20 divided by 12, which gives me $3.85. So it is $3.85 per gallon. Question 3. Well College in Aurora, New York was previously an all-girls college. In 2005, the college began to allow boys to enroll. By 2012, the ratio of boys to girls was 3 to 7. If there were 200 more girls than boys in 2012, how many boys were enrolled in that year? Use a table, graph, or tape diagram to justify your answer. So we have girls, boys, and then I'm going to write difference because we want to see what the difference is. And you can do this with a graph. You can do a tape diagram, whatever. I'm going to put the phone down for a second to create the table. 1 second. So here is our table. And again, you can do it any way. You can make a tape diagram. You could create a graph. Whatever works best for you, whatever makes more sense is totally fine. So our basic ratio, the ratio that we're working with is 3 to 7. So I'm going to have a 3 to 7 ratio. And then what I'm doing, that's 7 to 3. Sorry. And then what I'm doing is I'm subtracting them. So 7 minus 3 is 4. Well, I need a whole lot more kids than that. So I'm going to multiply that times, I'm going to multiply each of those times 10. So 7 times 10 is 70. 3 times 10 is 30. And again, I'm going to subtract those to find the difference. That's 40. Okay, we're doing better. Let's multiply it times 40. No, let's do 30. No, let's do 20. Sorry. All right. So 7 times 20 is 140, as you can see. And 3 times 20 is going to be 60. Again, I'm going to subtract those. So 140 minus 60 is 80. Still not there yet, but I'm getting closer. All right, let's do times 30 then. So 7 times 3 is 21. Add a 0 for 210. What am I doing? 3 times 30 is 90. Again, I'm going to subtract those. So 210 minus 90 is 120. Okay, getting better. Not quite there yet. Let's multiply them times 50. So here we did times 10, times 20, times 30. Let's try times 50. So 7 times 50 is 350. And 3 times 50 is 150. I think we found it. So 350 minus 150 is 200. So this is where we have our answer. So there are 350 female students and 150 male students. All right, question 4. Most television shows use 13 minutes for every hour of commercials, leaving 47 minutes for actual shows. One popular television show wants to change the ratio of commercial time to show time to be 3:7. Create 2 ratio tables, one for the normal ratios of commercials to programming, and another for the proposed ratio of commercials to programming. Use the ratio tables to make a statement about which ratio would mean fewer commercials for viewer watching. Okay, so we are making 2 ratio tables just like this to compare. So in this case, we're not actually finding the difference. We're just kind of comparing them. So again, I'm going to put the phone down for 1 second. All right, so the ratios that we have are for the regular, I have 47 minutes of viewing and 13 minutes of commercials. What they want to do is they want to have 3 minutes of commercials and 7 minutes of viewing. So here, these values are pretty far apart, so I'm going to jump those up quite a bit. So I'm going to start I'm going to start with 5 for this one. So 7 times 5 is 35. 3 times 5 is 15. So that's going to be the same there. I'm still not quite to 47. So let's do times 7. So 7 times 7 is 49. And then 7 times 3 is 21. So here I have some values. I have this 13, which is similar to 15, and quite a big difference in viewing time. And then here I have 47 is close to 49, but 13 is quite off from 21. So I have quite a bit of difference there. Let's multiply this one times 2. So 47 times 2 is 94. And then 13 times 2 is 26. Let's see if we can get to a value close to 94. So I'm going to take 94 and I'm going to divide it by 7. That gives me 13. So let's multiply this times 13 and compare our values. So 13 times 7 is 91. And 13 times 3 is 39. So here I have numbers that are similar, but I have numbers here that are quite different. And then let's try times 14. So 7 times 14 is 98. And 14 times 3 is 42. So again, if I'm comparing this set of values with this set of values, I have numbers that are similar here, but numbers that are way different here. And even if I'm looking at this times 7, I have similar values here and similar values here. So what we can learn from that is that the regular programming gives more viewing. All right, so that is all of the answers for the review. Please reach out if you have any questions and bring this with you tomorrow to use, and good luck.